we have a rectangle, and we have some side lengths given in terms of the variable x. And it's asking us for wx. Now in this topic, it's important to know that all the sides have to be accounted for. And this is a rectangle, so the opposite sides are equal. So if I have 3x on the vy side, I also have to have 3x over here. And if I have 4x plus 3 on the bottom, I also have to have 4x plus 3 on top. So now that all the sides are labeled, let's go ahead and make our equation. It says the perimeter, which is all the sides added up. So right here, so I'm going to add all my sides of 3x plus 4x plus 3 plus 3x plus 4x plus 3. So that looks confusing. I'll go ahead and highlight it for you. So this 3x and 3x come from, not that 3, right here and right here. And then in green, I'll do the 4x plus 3 is right there, and the other 4x plus 3 is down here. So all of that added up, and this is equal to our perimeter, and it gives the perimeter is 146. So I'll add that up. That's going to be 14x plus 6 is equal to 146. Now in solving the equation, it's important to know that we always take care of the plus and minus first. So I'm going to go ahead and subtract 6 from both sides. Give me 14x equals 140. And I know that a number right next to the variable is multiply. So I'll go ahead and divide by 14 on both sides. So x is equal to 10. Now, many of you may be tempted to put in 10 as the answer, but it's not actually asking for x. Sometimes it will, but in this case, we're actually asking for wx. So on my picture, I see that wx is right here. Put a nice thick green marker. So wx is right there, and it's equal to 3x. So I know that x is equal to 10, so if wx, the side length, is equal to 3x, I'm going to plug in x equals 10 here into this x. So it'll be wx is equal to 3 times, go ahead and color code that, 10. So wx is equal to 30. So the correct answer for this problem is 30. This is again the second example of finding a side length given the perimeter and side lengths with variables. In this case, all the sides are given, so all we have to do is add up all of our sides. And in this case, our variable is z. So I'm going to say 3z plus 11 plus z plus 2 plus 2z, make that actually z, plus 1 plus 11 again is equal to, and our perimeter is up here, so 67. So let's go ahead and color code that just so we can see where everything's coming from. 3z, 11. I'll do the same 11s over here. They're both 11. Z plus 2 is right here. And then lastly, 2z plus 1 is right here. And then obviously our perimeter, which we can do like a darker blue. 67 comes right from our perimeter here. And all we have to do is solve this equation, because in this case, it's asking us for z directly. It's not asking us for a side length. So I'm going to add all my z's together. I like to square my variables. So I have 1z here, 2 z's there. So 3 plus 1 plus 2 is 6. So 6z. And my numbers, I know that's going to be 11, 13, 14, and 25. So plus 25 is equal to 67. Now I'm going to, again, take care of my plus or minus first. So minusing 25 from both sides. I have 6z is equal to 67 minus 25 is 42. And then again, I know if I have two things next to each other, it's multiply. So dividing by 6 to cancel that out. And then I have left z is equal to 7. Solving a word problem involving consecutive integers. This topic may seem complex, but once you know the patterns, it's actually not that bad. So we don't know these integers, but let's just suppose we take example integers. I'm going to say 3, 4, and 5. These are consecutive integers. Consecutive meaning one after another, and integer meaning just non-decimal numbers. So if I ask myself, how do I get from 3 to 4? Well, I'm going to add 1. All right. And how would I get from 3 to 5? I would add 2. So if I know the first integer, I know that first mystery number, I can just add 1 and add 2 to get the next ones. Now, it's true in this problem, I don't know my first one. So I'm going to call that first number x. So I'll say x. Well, if that's x, the next number would have to be x and then plus 1. I'm adding 1 to get the next number. And then the third number in a row would be x and then plus 2. And this plus 1, plus 2 pattern comes up a lot, so just keep that in mind. Now this problem asked for the sum, and sum means to add. So we're taking these three numbers. This is the first number, this is the second number, and this is the third number, and we're adding it together. So my equation is going to be x plus 1 plus x plus 2. Maybe this will help to group them. There's our first, second, and third numbers. All that equals 57. So I'm going to add my equation together. I see that I have x's. So I have 1, 2, 3 x's. So 3x plus 3 is equal to 57. Again, I'm going to take care of the plus 3 first, so I'm going to subtract 3. So cancel that out. So 3x is equal to 54. And what I'll do is divide both sides by 3. 54 divided by 3 is equal to 18. So x equals 18. Answer's done, right? Well, no, because it's asking for 3 numbers. I know x is the first number, so I can put an 18 there. All right, but the next 3 numbers are kind of given right here. X equals 18, so that number would be 18 plus 1. Let's make that 18. And then 18 plus 2. So my numbers are actually 18, 19, and 20. And if I want to check that, 18 plus 19 plus 20 do add to 57. This is the second problem of 2 in the solving a word problem involving consecutive integers. But this time, the main difference is that we have this word even. Doesn't seem to change much, but it actually changes a whole lot. So let's take a look at 3 consecutive even numbers. I'll start with 8 and go to 10 and 12. So even numbers are all those numbers ending in 0, 2, 4, 6, or 8. And they are all divisible by 2. So now, how would I get from 8 to 2? We know from our past example, this first number is going to be our mystery x. So we have to add 2 to get to our next number, and actually add 4. So plus 4. So my pattern is going to be x plus 2, and x plus 4. All right. Now that's the even case. I know this problem doesn't cover this, but what about the odd ones? Let's take 3 odd numbers. Let's go 9. Next odd number after that would be 11, and then 13. This is the odd numbers. Now our first number is going to be x. So again, we're going to add 2 to get to the next odd number, and actually add 4. So despite it being even or odd, whether or not the problem says even or odd, the pattern's still the same. So x and then x plus 2, and then x plus 4. So that same setup you would use for even or odd, whereas the regular consecutive without even or odd would just be the plus 1 plus 2. All right, let's set up our equation. We know these are our numbers. So it's our first number, our second number, and our third number, and they have to have a sum of 48. So again, sum means add. So x plus 2 plus x plus 4 all equals 48. I'm going to recognize that I have 3 x's again. So 3x plus 6 equals 48. I'm going to go ahead and minus 6 from both sides. So 3x equals 42. And divide by 3 on both sides. So x is going to equal 14. So again, we're not done yet. That was our first x. But again, our numbers are right here. In fact, let's move that down. So this is 14. Our numbers are going to be 14 plus 2 and 14 plus 4. So that means our numbers are actually 14, 16, 18. And those are the numbers going into ALEKS. So 14, 16, 18 will add to 48. Now this topic comes in a bunch of different varieties, but the premise remains the same. We're going to be distributing. We have variables on both sides, add and subtract. A whole bunch of things can go on. And this spans about 4 topics, whether or not you have one distribution or 2 distributions, or variables on the same side, variables on both sides. So just keep in mind that the skills I go over in this one topic kind of translate to all of the solving equation things. In our problem, which I'll rewrite here, I have negative 3u minus 8 plus 3u equals 6 parentheses u plus 3. All right, now my number one suggestion for everyone, if you haven't done this in the past, I encourage you to try this, is to draw your line down the middle. And you might think this is an unnecessary step, but it helps you stay organized. In these very large problems, a lot can get messed up. And having that line kind of helps you, make sure you're doing things right, making sure your work is nice and neat. So I always suggest doing that. Beyond that, our step 1 is going to be anything with parentheses. So those parentheses, I want to take care of those first, and we're going to do what's called distributing. So distributing is the process of, for example, here, taking that 6 and multiplying it against everything in the parentheses. So I have 2 of those. I'll do it in red. So I have negative 3 times this, negative 3 times that. And then I have 6 times u and 6 times 3. So I have 2 distributing and 2 percents of parentheses. So the first one I have negative 3 times 3u right here. I have negative 9u. And I know a negative times negative is a positive, so negative 3 times negative 8 is positive, so plus 24. And I'll copy down the rest of it, so 3u equals, and then over here I have 6 times u, which is 6u. Make that a bit neater. 6u, and then 6 times 3 is 18. Pause. All right, our next step is to combine like terms. So like terms are anything with variables or just plain numbers. So in this case, my negative 9u and my positive 3u are both on the same side, which is very important. So they're both, again, over on the left-hand side here. So there's my two terms. And they both look the same. So in this case, they both have a u in them. So again, to combine them, we need to be on both the same side, either the left or the right. They both have to look the same. Either those. Also, if you had something like negative 10 and 14, those both don't have u's, so those are okay to combine. So here, negative 9u, there's a thinner pen here. There we go. Negative 9u and 3u is negative 6u. And I'll bring down my plus 24. And there's nothing to combine on the right-hand side because we have just one u and one plain number. So there's nothing to combine there. We're going to keep that as is. All right. My next step is to pick a side for your numbers, pick a side for your variables. It doesn't matter which, the answer comes out the same. So I'm going to call this pick sides. I typically like my variables on the left-hand side, so I'm going to say this is my variable side. I just label it up there. You don't have to. This is my numbers, or my constants, you can call it too. So plain numbers with no variables and my variable side. Or you can put a V and an N, or whatever you want to do, or don't write anything, and just know that all your variables are going there. So let's go through what our variables are. So here, there's the variable, and there's the variable. Now, the negative 6u here is good. It's already on the variable side. However, this one is on the number side. It's on the wrong side. We have to move that. Right now, it's a positive 6. So to cancel it out, we have to do minus 6 to both sides. So minus 6u minus 6u. I like to draw a nice big horizontal line whenever I do that operation there. So now a plus 6 and a minus 6 right here, these cancel out, become 0. And a negative 6 minus 6 is a negative 12u. And I'll just copy down the rest of that. All right, so going back to the problem here, my numbers, the number side has to be on the right-hand side. So my numbers are good here. Those are okay. But these have to get moved. They're on the wrong side. This is variables only. So to get rid of a plus 24, I'm going to do minus 24 and minus 24. Those go away. So I have negative 12u. Make that a little neater. Negative 12u is equal to negative 6. Okay. And last but not least, I'm going to divide both sides by the number next to the variable. Divided by negative 12, divided by negative 12. And this you can type in the calculator or simplify it yourself. And a negative divided by a negative is a positive, so we have a positive 1/2. That simplifies to 1/2. There you go. All right, this is the second problem in the set of the complex solving equation things. Again, this spans a couple topics, but all the skills kind of remain the same. So I'll rewrite our problem, make it a little bigger for us. So I have negative 2 times v plus 5 equals 8v minus 9 plus 2v plus 3. And again, my step 0, if I were to write a step for it, is to draw a line down the middle. Okay, now my real step 1, I've written up here in a little shorthand, is just parentheses. So I'm going to take care of any parentheses I have. I see I have 2 sets. So negative 2 times v is negative 2v, and negative 2 times positive 5 is negative 10, but you wouldn't write plus negative, you just write minus as a negative. So equals, the rest of this will stay the same for now. And then over here, 2 times 2v is a positive 4v, and then 2 times 3 is a positive 6. All right, that step is out of the way. We're going to combine like terms now. So I'll use green for my combine like terms. I see on the left-hand side, everything is different. There's no like terms there. So not much to do there. I'll copy that down for now. So I have just negative 2v minus 10 equals. Now over the right-hand side, there's lots of things going on here. I see that I have 8v and a positive 4v. So 8 plus 4, this is a positive, so 8 plus 4 is 12. So that's 12v. And I have to circle my ones. So negative 9 plus 6 is minus 3. All right, next, so we've done our combine step. We have to do our pick sides. So I'm going to choose the other side. Usually I do the left. I'll do the right for the variable side this time. So my variables go over here, and my numbers, or my ones I can call it, maybe ones or numbers, variables, whatever, go on that side. So I know I have a variable here. That's good. But I see I have more variables on the one side of the numbers side. Let's call the numbers, the plain numbers. So I have to move this one. So again, it's a negative 2v, it's a minus 2v, so I'm going to add to cancel it out. Negative 10 is equal to, and this becomes now 14v and minus 3. Now I see that I have all my variables on that right-hand side, but this needs to move because this is good over here on the ones or the numbers side, but that minus 3 has to move. So to get rid of a minus 3, I'm going to do the opposite, or the inverse operation. I'm going to add 3. Negative 10 plus 3 is negative 7 is equal to 14v. And I know that that's going to be a multiply there, so I'm going to divide, do the inverse operation again to get rid of that. So v is equal to, and this will simplify to negative 1/2. This is a topic I always get questions on. This is identifying solutions to a linear equation in one variable. I think it says two-step, maybe. The point of this is to test solutions to the equations. So I have an equation here. It is 2 equals w minus 7, or divided by 7, minus 2. And it's saying, is negative 42 a solution to this equation? Well, it's basically testing w equals negative 42. So my equation, in place of w, I want to get rid of w and replace it with negative 42. So this number that was right here is just going in place of w. And I'm going to simplify that. So 2 equals, and this right here is negative 6 minus 2. I can simplify that. So 2 equals negative 8. That does not work. That is not true. So we put not equal to. And this means if it's not equal to, it means it's a no. It's not a solution. So we're going to mark off no. All right. Now, sometimes when I write this workout, before I know that it's the same or not, I might put a question mark over my equal sign. So if you see that, if you see me do that in class, that's what that means. I'm not sure if it's equal. On to the next one. 2 equals 7 divided by 7 minus 2. Well, 7 divided by 7 is 1. So 1 minus 2. This, again, is not equal. Not equal produces a no. So it's a no for 7. Two is equal to negative 49 divided by 7 minus 2. Negative 7 minus 2. 2 does not equal negative 9. I'm just doing the math quickly. But this is also a no. Last but not least, we'll see if we have any yeses here. We're going to test 28. So we're testing out 28 here. I'm going to say 2 equals 28, which was where w was, divided by 7 minus 2. And that 28 goes right in place of w. 2 is equal to 28 divided by 7 is 4. So 4 minus 2. And so 2 does equal 2. This is a match. Hooray. They are equal. It's good. That means, yes, we have a solution. We can mark off yes. It is also possible to get all no's for this, so keep that in mind. If you get all no's, it doesn't mean your answer is automatically wrong. It is rare, but it is possible to have all no's for your answer. All right, this problem is solving a decimal word problem using the linear equation of the form, and this is the missing words here, ax plus b equals c. So let's break that down. This first number next to the variable, and the variable could be not x but something else, there's always a variable involved, is the change each time. And in the problem, you look for keywords. You're going to look for the words each, every, and per. Now these are the main three. There are others, but this is kind of a good starting point for words to look for to identify what number goes next to x. Now the b is your starting value. Now there's not really key words for this like there is for a, but you're going to look at things like, what did this person start with? What was, before anything else happened in the problem, what was in this case the value of something? Or, what happened at the very start of the problem? On the opposite end of that, this is sort of your final. So what's happening at the end? So how much money did someone have at the end of the word problem? How much distance has the person traveled at the end of the time period they were traveling. So that has more of like a final number to it. So let's read the problem together and figure out some important information. Cameron received a $90 gift card for coffee. That's at the very start of the problem. So my guess is that this starting value is going to be our $90 gift card. Nothing's happened to Cameron yet. Carmen. Nothing's happened to Carmen, and it's just $90. All right. She's used it in buying some coffee that cost $8.53 per pound. Now, isn't that interesting? We have the word per in our word bank here and the per here. So my guess is that $8.53 goes right with A. All right. And then the final. All right. After buying the coffee, so she's done buying her coffee, and she has $64.41. So that number is the final number here. So now there's some rearranging I want to do. We're starting off with 90. So my equation is going to be 90 as our starting number. But I'm going to swap these two variables. And I'll tell you why. We're starting with 90, but she's spending it. She's buying some coffee. And ultimately, if you have a gift card and you're buying some coffee, the value of that gift card is going to go down. We're going to use money. So we actually have to minus $8.53. And let's call it P for pounds. So P is equal to the number of pounds of coffee. The minus is just because she's spending it. If they were adding to her gift card or giving her extra money on the gift card, we can add, but she's going to lower her balance on the gift card. And the final number is 64.41. And again, it's kind of telling that the minus is there. It's nice that the 64 is there to remind us. So we're starting at 90, and we're going down to 64. So clearly we need the minus in there to make it go from 90 to 64. Let's go ahead and solve that equation. The first thing I'm going to do is get rid of the number by itself here, actually. So this is a positive 90. So to get rid of that, I'm going to subtract 90 from both sides. That will go away. The negative stays with the 8.53, so negative 8.53. P is equal to, take my calculator off screen, I'm going to do 64.41 minus 90. And it's a negative, that's okay. It's negative 25.59. Now this is a multiply, so I'm going to divide by the whole number here with the negative, so negative 8.53. So my answer, whatever this comes out to be, so P is equal to, I'm going to do this calculation in the calculator right now, so negative 25.59 divided by negative 8.53 gives me P equals 3. So 3 pounds. P equals 3 pounds. There you go. This is our second problem in the topic, solving a decimal word problem using a linear equation of the form AX plus B equals C. So now let's review. AX plus B equals C. This is going to be our change, or each, every, and per. Those are our key words we're going to look for. B is our starting value, and C is our final or ending value. So if you read through the problem, for his long-distance phone service, Miguel pays $2 a monthly fee plus 12 cents per minute. So already I'm seeing two numbers which I can use in my problem. So we're talking about each month. So he starts off by paying $2 a month. Now you might think that's like every month or each month. meaning it should be A, but right here, 12 cents per minutes. So there's our key word we're looking for, per. It's right there. So I know that's going to be the A value. So this must be the B value, or starting for the month. We're talking about 1 month, so $2 is our starting value. As I said, last month, Miguel's long distance bill was $25.28. So that's going to be a final amount. So let's write that in our problem. So we have 12. And we're going to call the minutes M. So M is going to be equal to the number of minutes. So 12 and M plus 2 is equal to 25.28. Now there's a mistake with this problem right now. I've written it on purpose because everyone makes this mistake. And it's okay, you might eventually too. You might not. But hopefully watching this, you won't make this mistake. This 12 right here is incorrect. And the reason it is because notice that 2 is in dollars. This is $2. If I were to leave it just 12, that means $12. We're not paying $12 per minute. That'd be very expensive. It's 12 cents per minute. So 12 cents, I'll make that for a cent sign, is $0.12. So we actually have to put 0.12 to represent 12 cents. So now it is correct. I'm going to do our problem. All right. Again, we have a plus here, so I'm going to do a minus on both sides to get rid of that. And I'll draw my line down the middle. Keep myself nice and organized. My plus 2 and minus 2 do cancel out. So I have 0.12 m is equal to 23.28. I'm going to divide this next, dividing both sides by 0.12. My calculator off screen, I'm going to do 23.28 divided by 0.12. I'm going to get m is equal to 194. And that's it. This topic is solving equations with 0, 1, or infinitely many solutions. This is going to be a kind of confusing topic for some students, but the math is relatively simple. I'm going to go through a couple of these examples and see at least one example of a 0, 1, or an infinitely many solutions. Let's take our first equation. Negative 2 x plus 3 equals 3 x plus 4 plus 7. We know from previous examples that we have to do parentheses first. So I'll do all that out. I'll draw my line down. So negative 2x minus 6 equals 3x plus 12 and then plus 7. All right, I'm going to combine like terms now, so I see that these two can be combined. The rest of it stays the same. Negative 2x minus 6 is equal to 3x plus 19. I'm going to go ahead and notice that I have variables on this side and variables on this side. I'm going to go ahead and add the 2x to both sides. So I have negative 6 is equal to 5x plus 19. I'll then subtract 19 from both sides. So that's negative 25 is equal to 5x. I'm going to go ahead and divide by 5. And x equals negative 5. Now this may seem like a normal problem, and it is, because this is an example of one solution. If it's a normal problem where you just have an x equals answer at the end, that is an example of one solution. So what you're going to do here is click on this box or little button first, and then just type in negative 5. onto the next one. And this one is not going to be one solution. Just a spoiler alert. So here I'm copying the problem. And I'll do my parentheses. If you're unsure of what I'm doing here, I would just go back to previous videos where I explained more about this. So I'm multiplying through that. Next, I'm going to combine like terms. So I see that I have u's on the same side I can combine. Again, I forgot to draw my line down. Very important. So negative 2 plus 6 is 4u. So I'll do 4u minus 12 is equal to 4u minus 12. And now, if at any point during the problem, it's the same exact thing on both sides, you're done. I will go further, but you can get an answer from here. So we'll go back to this. I'll show you how we can get an answer directly from here. If I were to go ahead and subtract 4u minus 4u, both sides actually cancel out. So I have a negative 12 equals negative 12. And you can go a step further and add 12 to both sides, and both of those will cancel out. So since we have 0 equals 0, no matter what u is, we can put u to be 100, or u to be 10,000, or u to be 1. This 0 equals 0 will always be true. So it's important to say always true. So no matter what u is, we have a solution. So if at any point you have the same exact thing on both sides, right, the solution will always be all real numbers are solutions. And that's because with any number in here, the equation is going to be always true. So for this bottom one, we have all real numbers are solutions. All right, this is our second second example in the topic of solving equations with 0, 1, or infinitely many solutions. So again, we've seen an example of one solution already. We've seen an example of infinite solutions, or all real numbers are solutions. We're now looking for an example of no solution. And one of these will be that. Let's do the first example. 2u minus 1 plus 8 is equal to 6 times 2u minus 4. My first step is to distribute. Get my skinny red pen out. So I have 2u minus 2 plus 8 equals, here's my second distributing, 12u minus 24. I'm going to combine like terms and also draw my line down. There's the like terms here. And they have to be on the same side. So 2u plus 6 is equal to 12u minus 24. Now, if I pick a side for my variables, I'm going to pick the right-hand side. So I want all my variables on this side, which means this 2 has to be moved. So I'm going to subtract 2u from both sides. Those cancel out, so I have 6 is equal to 10u minus 24. Let's draw 24. There we go. Now, since my variables on the right-hand side, my 1s or my numbers have to be on the left-hand side. So I'm going to add 24 to get rid of the 24 here. I have 30 is equal to 10u. I'm dividing by the number next to it. So I have u is equal to 3. Now, right off the bat, I knew this was going to be a one solution. And the reason why I did is because my variables did not cancel out. Whenever your variables totally cancel out and go away on both sides, we have either no solution or all real numbers are solutions. But right in this step here, we can just take a look back. When I tried to move the variables, I still had variables left over. They didn't cancel out. So right then and there, I knew it was going to be a one solution. You do have to finish the problem to figure out what the one solution is, but I know as soon as my variables don't cancel out, so right in this step here, that I have a one solution problem. On to the next one. And I've promised you a no solution, so this one's going to be no solution. Let's look for how we know it's no solution. First, I'll write the problem. Go through my distributing. And draw the line down. So this is going to be 6 plus 3y minus y is equal to 6 plus 2y plus 2. All right, I've combined terms here. So 3y and y as well as 6 and 2. So it's 6 plus 2y equals 6 and 2 become 8. And then plus 2y. It says subtract my y's to bring them together. And right here, like I said before, my variables are canceling out. There's no more variables, which means I either have no solution or all real numbers are solutions. Now, what makes this example different is because 6 does not equal 8. This is always false. No matter what we plug in for y, we can plug in 100 or 10,000 or 1 or 52 or 47, whatever it may be. We will always get a false answer because 6 is never equal to 8. No matter how you try to explain that, it's not going to be true. So no matter what we have, we're not going to have a solution. So this answer is no solution. This topic is solving a two-step equation with signed fractions. This is probably the hardest topic you will find in Goal 1. Now, I don't know if it's on the test. I don't think it's on the test. However, this is a necessary topic to unlock something all the way in Goal 5, which is all the way at the end of the course. People do skip this topic, but eventually they have to go back to it. So while you're in Goal 1, you might as well take care of it and have some nice examples that you can go off of in this video. My first step is to write the equation out, obviously. So 1/2 w minus 2/5 equals negative 2/7. Now, the key for this problem is to find a common denominator. So you want to find a common denominator for all of your denominators. So for 2, 5, and 7. Now, if you're unsure of how to do this, what you can do is actually make a chart. You can say 2, 5, and 7, and do all the multiples out. So 2 times 1 is 2, 2 times 2 is 4, 6, and so on. Same with 5. 5 times 1 is 5. 5 times 2 is 10, 15, 20, and so on. And same with 7. 7 times 1, 7 times 2, 7 times 3, and so on. Now, in some cases, you will find that pretty quickly. In other cases, such as this particular case, it won't happen until 70. And I won't explain how I know that, but the lowest common denominator is actually 70. A shortcut to getting this, if you don't want to do this table out, you can find a common denominator by multiplying all the denominators. So if I do 2 times 5 times 7, it happens to give me the lowest common denominator. But if you're stuck, that will give you a common denominator you can use. Okay, so that's kind of step one. Common denominator. What I will say with this topic is that there's lots of steps, and the neater your work is, the less mistakes you're going to make. So please follow along carefully and try to write this as neatly as you can in your notes. The next step, step 2, is to multiply common denominator, I'll call it CD for short, times all the fractions. So multiply common denominator to all fractions. And I do it off to the side. So I'm going to do 70 times 1/2. I'll take each of those individually. Now, for this problem, what you can do is you can kind of put a pretend over 1 here on the problem. So 17 times 1 is 70. 1 times 2 is 2. Multiplying straight across. And if you divide this, you get 35. So that number is going to be very important just in a second. And that was for the 1/2. There's that. Now let's take our 70 and we're going to multiply it by, and we'll take the negative with us, so negative 2/5. And again, we're going to put that over 1. So 70 times negative 2 is negative 140 divided by 1 times 5 is 5. And that should give us 28. Use my calculator. I'll call that orange. And last but not least, we have the negative 2/7. So I will take 70 again and multiply it by negative 2/7. So over 1, negative 140 divided by 7, that should give me negative 20. So let's do it in blue. So there's our negative 2/7 and negative 20. Now the reason we did all of that is this right here. So we're going to take our equation again. 1/2 W minus 2/5 equals negative 2/7. And you can balance out your equation however you want to. If we're going to multiply by something on one side, so I'll do 70. I have to do it to the other side. This equation has not changed. It's remained the same because we balanced out our math. So I'm multiplying on the left-hand side 70 and on the right-hand side 70. But what it does for us is it's going to eliminate all of our fractions. Notice in these 3 new numbers we have no more fractions. So this first step, while it seems complicated, makes our life a lot easier. So 70 times 1/2 is 35W. Now 35 came from our math up here. There's a 35 right up top. And 70 times negative 2/5 is minus 28. And our minus 28 came from our math up top again. We did that out ahead of time, so we know what the math is. And that's equal to, our last one was negative 20. And there's that right there. So these two equations, that more complicated fraction-looking equation and the whole number equation, actually will have the same exact answer. So let's go ahead and solve that equation right now. And draw the line down. I'm going to add 28. I see a minus 28. I'm going to add 28 to both sides. I'm getting 35W is equal to 8. Dividing both sides by 35. And I know that can't simplify, so my final answer is just going to be W is equal to 8 divided by 35. Now this is going to seem weird to you to get this crazy fraction of an answer, but actually most of the time, if not all the time, these problems have answers that are weird fractions. So the answer to this one is actually 8/35. This is our second problem of 2 of this topic that's solving a two-step equation with signed fractions. This is probably the most difficult topic in Goal 1, but again, it's worth your time and it's required to finish off Goal 5, which comes later in the course. So our first step we're going to do is actually write the problem out and then find a common denominator. So in this case, I know in the last example I said it just multiply everything together and you have your answer. In this case, we're actually going to write all the factors out to see if we can find a smaller factor. So I'll do the 3 times table out. So 3 times 1 is 3, 3 times 2 is 6, 9, let's go to 12, and then 15. The 2 times table here, so we have 2, get 2 first, so 2, 4, 6, 8, 10, 12, 14. And then for the 4 times tables, 4, 8, 12, 16, 20. So if you notice here that the 12 appears first in all of the columns. All right, so that is our lowest common denominator. So the lowest common denominator is equal to 12. If you were to just multiply 3 times 2 is 6 times 4, you get 24, which is a common denominator, but it's not the lowest one. And you know, easier math with lower numbers, I would prefer working with the lowest common denominator. So that's going to be 12 in our case. All right, so that was step 1, to find our common denominator. So our CD, or common denominator. 2 is to multiply our common denominator, CD, to all fractions. So I'll set that up like here. So I've set up all 3 of them. So really quickly, I'll do -1 times 12 is -12 over 3, which is -4. I'll go through and do the rest of these. This last one I'm going to do -12 times 7. 12 times 7, no, it's negative. So -84 divided by 4 is going to give me a -21. So again, these go right in place of the old number. So the 1/3 becomes -4. The -1/2 becomes -6. And the -7/4 becomes -21. And this is because we're going to multiply through by our common denominator. So the math we're actually doing is 12 times that right there. So when I distribute this, our new numbers take over. So we have -4 minus 6u is equal to -21. So we'll go through and highlight those where those new numbers are. There you go. Okay. Now we have to solve this equation. So I'm going to go ahead and add 4 to both sides. -6u is equal to -17 divided by -6 And u is going to equal a positive, because negative divided by negative is a positive, but a positive 17 divided by 6.